Hello there, and once again welcome to my workshop. Now we're going to continue with the MIDI CNC router build today, and hopefully by the end of this video we'll have quite a bit of construction of the gantry done, and we'll be hooking up to the y-axis, and well, we'll see how we go. So first of all, I need to mark out and cut some material. Okay, so I spent some considerable time cutting these and very accurately filing them, you know, nice and square, and finish them off nicely. Look, I will round the corners off when it's fully assembled. I've got a habit of knocking myself and cutting myself on edges, so you know, all those will be rounded off when I've completely built it. But I spent some considerable time, like I was saying, on these already, on the raw material. And what I'm about to do is to set up a small jig. Now a jig is just, it can be a reproducing, positioning, setup. In this case that's what this is, but it can be a lot of things. It's a tool that you make to assist you to carry out a process. So as I have invested a lot of time in making these, we're going to set them aside. Now I've drawn up a drilling strategy in Carveco, and to make sure I've got all my facts right, I have a piece of just 3mm aluminium plate that I'd rather sacrifice this if I've done something wrong. So I'm going to do it's really just it's a peck drilling, but I'm only going to go 3mm deep. Because this is 3mm, because I don't want to drill into my bed, okay? And I just want to make sure, after this has been drilled out, that I will actually bolt this onto the y-axis and the x-axis to make sure that everything is right before I go drilling through the main parts. So I'll show you now what I've done to enable me to clamp this down onto this bed, because the material takes up the whole bed and you've got nothing to clamp it with. So as it's just a drilling and it's no sideways pressure with a milling operation, this is quite okay. So what I have here is I have a retaining bolt in a T-slot nut, and that nut is just there so I can clamp down on something. So, and what I've done is I've got the tool here, and I know the tool is on the end of here, and I've got enough room here to move that direction if I have to, but I shouldn't have to, so I'm going to lock that up there. That now gives me a reference point that I can repeat and bring this material up to, up to a stationary position, and it's repeatable. So, having got that, I now need to clamp down, and I'm clamping it down on the bed here, and I'm using the actual the dovetail way here to actually clamp it down onto, so I've got to be careful. And I know I'm flush on that edge there, so I've got to get flush on this edge here. So what I'm going to actually do to stop this floating around, I've got a clamp here with a T-slot nut on, and just a couple of washers there too. If I can do this without being khaki handed. Okay, so I'm only going to grab on this by about 3 or 4 millimeters. Now I've got a couple of washers there just packing that end up. I've got to be sure that this doesn't hit this, because I'm working with a very short tool. And I just get a spanner and do that up. I think it's 14 now. Yeah. This is the main clamping device. That's the one that's really gonna hold it down tight, as long as it doesn't spit it out. Now then, the G clamps back here are just going to be as a backup. Okay, let's do this up a bit. Over the back. Oh, no, a bit too far down. Okay, that one's secure. Now here, you can get away with doing things like this too, providing you... Okay, well that's all okay. So now we're going to set up our 0, 0 on this corner here. And I'm going to do a dummy run, and I'll probably set it set the Z a few millimeters up in the air, and we're going to air cut this first just to make sure that this isn't going to hit this, or indeed hit anything at all. So we're going to come down in the Z quietly. Ooh, it's going to be very close, I think. Very close indeed. So already I can see that I'm going to have to move this up this way about 5 mil or so. I've got the G-clamps holding it there now, so I can unscrew this. And just move him back out of the way. Although I do know that the tool is going to track, it's going to drill in 6.5 millimeters up in here. Okay. You should be able to. I'm going to have to walk around the machine and just, because I can't actually see in through here. I think it's pretty damn close. I don't think it's quite far enough. That's pretty damn good. I'm just going to raise the Z up. Wrong direction. Up. I'm going to call that 0. I'm going to load the code, set all the zeros there now, and we'll give it a dry run. Okay, so I have now zeroed the corner of the material there. But you will notice here, I think you can pick that up, that the 0 of the job is in the center of the material, which is up here. Well, it's rather than me trying to mark out the center of the material and, you know, sort of jog over and try and visualize the center of the material, it's easier for me to zero that corner than just jog Mark 3 until the DROs read, you know, the correct value, which is very easy to do. So we need to go 70 millimeters up this way, roughly thereabouts, and we can get it fairly accurate. Very accurate. So this is 70 millimeters up this way, so I know that's the center of our job, because our job, when I wrote it, was 140 millimeters long and 80 millimeters wide. So we've got to come now 40 millimeters. Oh, too far. Okay, so what I can do now to get this exact is pull up the jog, okay, and reduce this down. Oh, 4% is okay. Maybe not. Okay, so we set this at 1%, which will make it easier for us to get. There you go, 40. So now, to make that the start of our work, or the center of the material, simple 0, 0, and always press regen. And I think you can pick up now that that is in the center of the piece of wood, although this is 100mm wide. So that now should be correct for our program. So now I'm just going to air cut this and just make sure that we're not going to bash into anything. But first I'll take the jog speed right back up again to 10%, and then we'll give this a run. Okay, so I won't have the spindle running. It's not, you know, it's not going to be used. So we're just going to run this quietly. I've got this set at 30% feed. See what happens. So now it's peck drilling. And you can see now why I moved that bolt over. But I'm still going to nick, I think, that. I may or may not. I'm going to stop the program there and just check. Oh, that's so very close. I think it's going to be okay. Okay, so now we're going to set the I think that's going to be okay, actually. Let's just reset the Z. Get a bit of paper. It's a simple method to get within 1/1000th of an inch or so. Whoops. Okay, that's about it there. So I'm going to reset the Z there. Okay, this time it's for real. Okay, I've got 4 on here, at least 1 on every bearing block with it's only just a nut just to space it out, because these screws are bottoming out inside the drilling of the bearing. But all holes line up, as you can see. Just get this out. And do this up front. Okay. Now the big test is, how free is this gonna, I mean look, it is absolutely solid there. I can flex it, but I can't move it laterally at all, which is exactly what I was after. And that's the big reason why you have 2 rails and not 1. So you can't move it laterally at all. I mean, I'm putting like 10 kilos or more on that either way. Can't move it. Now then, big test. Oh, look at that. That is so smooth. Just the slightest resistance. Turn it very easily with my fingers. Just one hand. Very easy. Couple of fingers. Right up to it stops there. That is beautiful. I'm very happy with that. So now this means that that program for doing that whole pattern, everything lines up, and now I'm good enough to go ahead and drill the main parts. So that's the next job.